Okay, now that I showed you how to do basic stuff and make your screen look like a VU meter, I will tell you some tips and tricks that you can do and make it look like you want. Let me increase font size. Here I programmed two lines on the VU meter. Here is a line that looks like a needle, and here is the rectangle that you can see below the line. Okay. As you can see now, the line is not very smooth, it bounces. Okay. Here I made a variable, the variable smooth. I will do this from 1 to 9. Let me write the line here. So I will program it that it is very smooth if it's 9 and not smooth if it's 1. Okay. And here, this line here, I will do it like that. Just wait that I find it. Okay. Here it is. Okay. So here the previous reading is multiplied by smooth divided by 10, which is, for example, if it's 8, this will be 0.8. So what is the problem with this? And last time that I did this, it didn't work. I declare this value as an integer, and it is an integer because it's 1, 2, 3, 4 up to 9. Okay, so it's always an integer. But on the Arduino, when you make calculations with a variable declared as integer, the results are always only integer. So this, for example, although it should be 0.8, it will be rounded to 1. So if we declare this variable and we want calculations with this variable to result to not an integer but a value with decimals, so this is called a float. And if I declare this as a float, now this will work. So it will be previous reading multiplied by 0.8 plus present reading multiplied by 0.3. It's 1 minus 0.8. Okay, so if I put here the 9, okay, now this will be very smooth. So I upload this to Arduino. It's done. I will here you see how slowly it moves up when I stop it. So you see, this is very smooth. Okay, you will never want it that smooth because it will not show you correct readings, but maybe a value about 5 is good. Let me show you now. Just wait because my phone rings. Okay. Now it's done. Let me show you now. You see, it is smooth, but I think this is okay. Now, let's learn some other things. You can see here that I get 50 samples per audio reading. If I want to make this max audio variable, I get 50 samples, also 50 moments in time. I measure the strength of the audio signals. Look what problem this does. I will put here play. Okay, so if I am above a certain frequency, the signal looks stable, but look what happens if I lower the frequency. Look here. Okay, as you can see, the signal on the OLED screen bounces, and this is because 50 samples are not enough, and I am not getting proper signal strength. This must be higher. What I will do, so let me show you. Okay, I will declare a variable here called samples, and I will put this higher number, for example 200, and here I will tell the program to get so many samples as this variable here is. That way we can making variables of all our parameters, we can easily make calibrations to our program. Okay, now it is uploaded. Do you see here? Can you see now? So now it's not bouncing. It bounces only when I speak, okay? So it bounces only when I speak. Normally it's not bouncing. So here, because I am getting so many samples, like 200 here, I deleted the delay. So after I get a max audio signal, I don't keep a delay before displaying it, and I don't keep a delay after displaying it. You can try some delays if you want and see if you can get some better readings, but I will leave it without delay. So I think these settings work okay from what I have realized. Now I want to show you something else. I will use this one OLED screen to display a second channel. So with one OLED screen I will have two channels. If I have two channels, I have to do all this stuff here 2 times. If I want a second OLED screen to display the other channel, I will have to use another Arduino. But if I want to use only one OLED screen, I can use one Arduino only. So let me show you. If we want to do this, we have to declare all variables twice. One for right channel and one for left channel. So I am copying and pasting everything that I have for readings to have separate readings for left and right channel. The smooth, I will not do anything with it because I will take 200 samples either for R or for left channel, so I just need one reading here. The smooth, I will not require different smoothness for right and left channel, so one variable is enough. Here I will declare pin A1 on the Arduino as my second analog input. It is possible that these two lines are not needed, but anyway, try if they are not there. If the program works without them, don't use them. So here max audio L, max audio R. Here R analog read A0, L analog read A1 this time. Okay, so max audio R, max audio R, audio R, and the same will be max audio. You see what I'm doing here? I think you understand what I'm doing. Audio L, right. So max audio R map max audio R, the same thing. Max audio L, okay, we are okay with that. I have to do this with that variable also. So max R, max audio previous R, max audio previous L, max audio R, max audio L. Now, and here at the end I have to do this also 2 times. So this is R, this is L, this is R, this is L. Now, what I'm gonna have to do, okay, so this is the display R channel, and I will do this one more time, and I will display here the L channel, but this line here is the line of 0. I will not use a line here, I will use a rectangle. Okay, so the rectangle will start at 10, max audio R, and thickness 10. Okay, here the rectangle will go up to 10, and 10 thickness will go up to 20. So I will put another line here at 30, max audio L this time, and with thickness 10. So what this will do, it will draw the right, it will draw the left, and it will display the display here. And then after it will get the readings, it will clear the display to display here the new readings. What we have to do now from the computer is that we just have to put the other channel to the other pin of the Arduino, which is here somewhere. Okay. We use 1K resistor for this. I have another 1K resistor, if you can see it here, and I will connect it. I will connect the other channel, which cable is here waiting. Okay, can you see it? All right. And through this 1K resistor that I have here, I will connect it to pin A1 of the Arduino. So I will do this now and come back. Okay, so I made all the connections. I took a close picture of the cables that I connected, and I will show it now. Okay, I hope you see it. So I made all necessary lines here, all necessary code required to display two channels. Now let's upload it. What I have here, look here on the serial print that was used so that we have on our computer screen the readings of the pin, but here it should be max audio L or R. Now max audio is not declared anymore, so here it doesn't find it and it shows an error. I don't need to display on my computer screen, so I will comment out this line. Now let's see now what we have. It's done. Ooh, look. Now we have two lines, one for left channel and one for right. Let's fire up a song and see how this thing looks. Oh yeah. Looks nice, doesn't it? So this now is actually, it shows us a stereo VU meter, okay? Let me show you, for example, if I press here the play. I guess you can see it. If I press the balance, look. One side, the other side. So it works perfectly. The two channels are not exactly equal. This is a problem of my sound card, maybe, I don't know, but I will not search for this. You see? Okay, I will stop it now. Another thing we can do, remember here this map command. This map command maps reading from 20 to 400. This is the input of our pin, and maps it, interpolates it between 1 and 128 so that we can display it on our screen. I think this is 0 to 127. I think that the first row and first column are called 0, and that's how it is. So the higher this number here is, I don't know if you can understand this, the higher this number, then the lower the sensitivity of our OLED screen will be. Do you understand this? I will show it as an example. Okay, what we can do, so we can make here a variable sensitivity equal, okay, we had 400, that's it, and we can take this sensitivity and put it instead of this. So what we can do, for example, if I put here 200, okay, I will upload it. It's done. I will press here play. So you see, it goes to the end. I will stop it. I will do nothing else. And this on the sensitivity here, I will put 600. I will upload it. Look. You see? So this sensitivity here, the higher I put it, the lower the sensitivity it is. This method, so I will put it now around 400, I think that's how it was. Anyway, this is a method to calibrate the VU meter. For example, we want to show on our VU meter the 0 dB of our equipment. And let's say the 0 dB for our equipment is 0.7 volts, okay? So what we have to do, is to feed to our equipment a signal 0.7 volts and then upload the sketch to our Arduino and show where the reading is. If it is below 0, okay, we have to decrease this value to increase the sensitivity. If it is higher than 0, we have to do the opposite. So playing with this value, we will finally make the Arduino show on our OLED screen the 0.7 volts to be exactly on the line. Do you understand what I want to say? I think this is very clear, okay? So we can keep this variable here. Now I will do something else. After the left channel, I will draw another rectangle, and this time the rectangle will be to say 55. The thickness will be here, but it will show look what it will show. It will show the average of our two channels. Let's see what we will see on this display. Done. And let me play the audio file. Okay, let me show you how it works here. Look. You see, what we can do, we can show a third line, and this line means the average value of our two channels. Isn't this nice? What else can we do? I will show you another way we can show a stereo reading on our display. I will draw a line here, and this line there is one line will start. This is the R channel, so right at the end. So and down 32. Okay, max audio, and I will comment out this line, and the right will be from 0 to 32, and it will go up to somewhere in the middle, let's say 40, with the height of max audio. So this will go, no, this will be from 100 to 8, let's say at about 70, and this will go at about 40. So now our reading will be vertical on our screen. So we have to use for this 63. So the values that will be displayed will have to be up to 63, because our screen is our screen has a resolution of 64. Okay, and here we have one line which will be displayed in the middle of our screen, let's say at line 20. No, at line 50, and height 20 up to 60 and line 20. No, let me see what I did good. I don't know. Let's fire up the one. What I have to put here R, and I have to put here L. Let's see what our readings now will be. What did I do? Okay, it seems I did something wrong and I did it upside down. Don't know why. So this should be 63 minus, and this should be 63 minus, so that the maximum, so the minimum is down, so it's 63. So it deducts this value. I would put here 64. Okay. Now the lines are not very symmetrical because I didn't bother here. Both lines start from pixel 32, so the height is 32. but here they are up to where? This is the problem. So if I deduct 127, let's say I deduct 50. If we deduct 50, 60, let's say 60. My mind is getting blown a little bit. So if I, let's see, this should be about 80, and this should be up to 50. Let's see now if both lines are symmetrical somehow. Doing some math and doing some geometry here would do it right straight away. Okay, you see, there is a reading at the bottom, which is the average value. We can this line, we can do it as a vertical line in the middle of our two channels. This should be 50, so it should be 55. No, this is right. This should be 55-20 up to 70-20, and here that this is the average, and I will put this okay, I will not do this now. And now let's see. Okay, let's see how it works with our signal generator here. Let's see the balance. Okay. So that works correctly. I think you have got the point how we can display different representations of VU meters on our screen, and I hope now it can be easy for you to draw your own representation, do it the way you want. This will be the end of this series of video, and by doing this series of video, I think we can make our life a little bit easier in case we have to replace an old analog needle VU meter from our vintage equipment if it is broken. Okay, that's all, and I hope you have a good time. Bye bye. Bye. Oh.